GCSE question of the week, week 7. A logo is made up of 4 congruent triangles. So for a start, we need to know what this word means. This word means they're the same size and they're the same shape. So if we cut one of those triangles out, we could overlay it on one of the other triangles. And it'd be exactly the same. Okay, find the perimeter of the logo. So the perimeter, we need to know what that word means. That means the distance all the way around the edge of the shape. So something like that. We need to work out that distance. Okay, so what do we know? We know it's 16 centimetres labelled here and 21 centimetres labelled here. So I'm thinking that if we notice that 16 centimetres has got to be made up of that distance there plus that distance there, then that tells us that the length of those triangles, or the height if you like, is 8 centimetres. So we've got 8 centimetres there. So the height of that triangle is 8 centimetres. Okay, let's tidy that up a bit. Okay, so we know that as that height was 8 centimetres and this triangle is congruent, then this length is 8 centimetres, and that's useful because that's one of the lengths we're going to need to know in working out our total perimeter. And equally, this length is 8 centimetres. Okay, so now let's have a look at this 21 centimetres. What can we find out from that? Well, we now know that we've got 8 centimetres here, and we've got 8 centimetres here, which makes 16 centimetres. So this length here, this width of this triangle, is going to be 21 subtract 16, which I make 5 centimetres. Now that 5 centimetres itself is not in our perimeter, but we're going to need to know that to work out our next length. Because we now need to think, well, what's this length here? But we can see that the total height of that triangle here was 8 centimetres, and we now know that this part of it is 5 centimetres because these two triangles are congruent. So if this was 5, and this is 5. So this length here, I think we can just do 8 subtract 5, and we get 3 centimetres. Okay, so now we know nearly everything we need to know, because we also know this length is 3. So that only leaves us the hypotenuse of each of those 4 congruent triangles. So that's the trickiest bit, but we're nearly there. Let's take that top triangle. We know that in that top triangle we've got a right angle there, and we know we've got a length of 8 and a length of 5. So it's looking to me that we need Pythagoras to work out the length of our missing side, the hypotenuse. And we know that a squared plus b squared equals c squared. And here, this is c. So we want to do 8 squared plus 5 squared, and that's going to tell us our c squared. So we've got 64 plus 25 equals c squared. So I make that 89 is equal to c squared, and square root both sides. C must be root 89. Okay, so we're there. The total perimeter, we've got 4 lots of root 89. That's this length, that's root 89. That's this length, that's root 89. That's this length, that's root 89. And this length, it's root 89. So we've got 4 of those. And we've got, what have we got? 2 lengths of 8. And we've got 2 lengths of 3. I think that's right, 2 lengths of 3. Okay, so we've got 4 root 89 plus 16 plus 6. We've got 4 root 89 plus 22. Okay, so we could leave an exact answer, or we could grab a calculator. So what do we get? We've got a root 89 times 4, and we've got plus 22. Let's to do it. So we get 59 what was it, 59.7. Do they specify a? Nope, doesn't say. So we can either leave it exactly, or we can say 59.7 if we're quoting a decimal. So let's say 59.7 to 1 decimal place. Forgot again. 59.7 centimetres to 1 dp. And we're done. Okay, let's have a look at the slightly harder high tier question. So this time we've got a sector. The area of this sector is 50 square centimetres. Find the length of the arc. Give your answer to 3 significant figures. Okay, so we could write a formula for the length of the arc. We know we need 60 over 360, because that's the fraction of the whole circle, multiplied by, find the length of the arc. So we want 2 pi r for our circumference. So that's what fraction of the whole circumference, 60 over 360 times 2 pi r. Okay, now straight away we're probably going to realise that that's our expression for the length of the arc. So if we put equals L for the arc length, that equation tells me how I'm going to work out the arc length, but we don't know the radius. Okay, so we're going to need this equation, but we're going to need to come back to it in a bit. So how are we going to work out the radius? Well, hopefully you've noticed that the area of the sector is 50 square centimetres, so we could write an almost identical equation, 60 over 360 times pi r squared, okay, which will give me the fraction of the area of the whole circle we want, and this expression here is equal to the area of our sector. But we know the area of the sector is 50, so we can make an equation that says 60 over 360 times pi r squared equals 50. Okay, now because the only unknown in that is r, we can solve that equation to find our radius, and then we can substitute that into the first equation, the one that we really wanted. So let's have a go. Okay, 60 divided by 360. I think we could turn that into a sixth. Okay, we could cancel the 2 zeros there, divide the top and the bottom by 10, that leaves us 6/36, that's 1/6. So we've got 1/6 times pi r squared equals 50. If we multiply both sides by 6, that's going to give me pi r squared equals 6 times 50. Okay, so 300. Okay, we've got pi r squared equals 300. What can we then do? Well, we can divide by pi. We divide by pi, we'll get r squared equals 300 over pi. And if that's true, it must be true that r, the radius, is the square root of 300 divided by pi. Now notice I'm going to leave that on my page. I'm not even going to work that out as a decimal, because that's going to leave that as an exact answer. So I'm going to leave all my rounding till the end. Okay, so now we know the radius. It's the square root of 300 divided by pi. And that was all we needed to know to use the first equation here that we wanted. So we're now going to work out the arc length. And we know the arc length is 60 divided by 360. But we already said that's a sixth. Times 2 times pi times r. And we now know r is the square root of 300 divided by pi. Okay. So now we can do some calculating. So entirely up to you how you put this in. You might want to make it look exactly as it is there on your display. I'm going to go for square root of 300 divided by pi. 3,300. Let's go for 300 divided by pi. Okay, so square root of 300 divided by pi. Let's evaluate that. And then let's multiply that by 2 pi. And then we've got a sixth of that. So it's the same as dividing that by 6. Okay, and I get 10.23326. I think if I remember, they wanted 3 significant figures. Okay, so I reckon the length is 10.2. 10.2 centimetres. Okay, now in class, I know some of my group got 10.3 centimetres. They'd done everything absolutely right, but they'd done some rounding maybe here, and that led to some rounding errors later on. Or maybe they'd rounded earlier, I can't remember. Okay, so the neat thing about writing this on your page is because we didn't do any calculating until this stage here, so we'd got everything we needed to get an answer. Okay, so I didn't do any rounding until the very last answer was in my calculator display, and then I was just going to put that to 3 significant figures, which is 10.2. So if you got a length of 10.2 centimetres for the arc length, fantastic, well done. See you next time.